Hello, welcome back to this channel. In this video we will be estimating the value of pi by using Gregory Leibniz series. So value of pi from Gregory Leibniz infinite series in Fortran. So let's have some basic idea about the theory of estimating the value of pi by Gregory Leibniz series. Okay. The Gregory Leibniz series given by James Gregory and Gottfried Leibniz is an infinite series written as this. Okay, and this expression says if minus 1 to power n divided by 2n, and if you take sum of whole of this term, then you will get the value of pi divided by 4. Okay, and on simplifying this we get the expression for value of pi as this, equation 1. Okay, where n takes value from 0 to infinity. Okay, as you can see here, and value of n must be positive integers. Okay, and we use formula 1. Okay, this formula to estimate value of pi in Fortran programming language. Okay, we will be using this formula while writing the Fortran code. Okay, and let's have some example for different values. For n is equal to 0, if we put 0 on the place of n here, then we get pi is equal to 4 times 1, only 1. Okay, this will be 1 and this term will be 0 and we will have only 1. Okay, 1 by 1 is 1. So for n is equal to 0, pi is equal to 4. Okay, and for n is equal to 1, pi is equal to, similarly if we substitute n is equal to 1, then we get this summation term as this. Okay, 1 minus 1 by 3, and of course actually there must be n is equal to up to, this means n is up to 1. Okay, 0 and 1. Okay, then we get pi is equal to this. Okay, or n is equal to 0, 1 and 2 up to 2, then we get pi is equal to 4 times this. Okay, and the terms inside the bracket is the summation term. Okay, and for n is equal to 3, similarly we get 4 times, let me add here times multiplications as this. Okay, and the terms inside the bracket is summation terms we obtain from this by substituting the value of n as minus 0, 1, 2 and 3. Okay, and so on. So in this way, expanding some terms in this term. Okay, for different values of n, you get, what you get is 4 pi by 1. Actually this is equation 1, and you can okay, you can put the 4 in with the pi. So I wrote here pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9 minus 1 by 10, 1 by 11 plus, and so on. Actually this is the alternatives infinite series. Okay, alternative means there are alternatively plus and minus sign. Okay, the terms where the plus sign is present is corresponding to the terms where the value of n is positive, even numbers. For example 2, 4 and so on. Okay, 2, 4, 6, and for the terms with a negative sign corresponds to the value of n which is equal to odd numbers, for example 1, 2, 3 and so on. Okay, the greater the number of terms, that is value of n, the more accurate is the value of pi. Okay, so That's why it is called the infinite series. Okay, if you go, if you sum many terms, okay, up to 100 terms, 500 terms, then you will get the more accurate value of pi. Okay, and we compare these values with the value obtained by pi, that is pi is equal to arctan 1.0, and calculate the errors. So we estimate the value of pi from this relation in Fortran, and we compare this value with the value of pi we obtain from this formula and calculate the errors. Okay, and obviously we will also plot the number of terms. Okay, number of terms and the corresponding values of pi in by using the gnuplot software. Okay, so if you want to see the proof of this statement, this expression, okay, then you can go to the link provided in the description. Okay, and to prove this relation, this expression infinite series, this expression is used. Okay, pi is equal to arctan. Okay, and arctan 1 is written in terms of a variable x. There are few steps simplification and you get the approximate expression for pi as this. You can see yourself. The link is provided in the description. Okay, so now let's move to write the code, Fortran code. Okay, so for this I have created a folder here. It is Gregory Leibniz folder, this, and let me open it, and there is I have saved this file. Okay, and now here I want to create Fortran code. So right click and open in terminal, choose this option. Okay, and here I need to create a file. Okay, I create the code in gedit, and let the file name be gl Gregory Leibniz. Okay, and it will have the f90.f90 as extension. Okay, and just press on enter, and the gedit opens like this with the file name gl.f90. okay, this is Fortran 90 version. Now I will be writing the code on this file and to the code to estimate the value of pi. Okay, so first of all let's name the program as okay, it will be gl method. Okay, and also there should be implicit none. Okay, let's define the variables in, declare the variables in double precision, and that will be pi real. Okay, I mistake, double precision. Okay, that will be pi real, pi estimate, and of course we will also have error. Okay, and we will also need a term as someone. Okay, and we need to also define integer, two integers here, let it be n, I and n. Okay, after dividing this we need to write the code for entering the number of terms, that is n. N means number of terms. Okay, and this is the real value by using the arctan, and this will be the value of pi estimated from the by using the formula of Gregory Leibniz series, and error and so on. Okay, now to write to enter the value of the number of terms, we need to write the code like insert. Okay, insert the value. Okay, value of n. Okay, this means number of terms, and let also remind you that n should be in n should be integer. Okay, do not insert decimal values. Okay, then the program will read the value of n. For this we need to use read command. Okay, let it be n. Okay, after you enter the n, the software computer will read the value of n. Then let we use do loop. Okay, let me define first someone is equal to 0 dot d0. Okay, d means for double precision we use d. Okay, and then we use do loop. Do I takes value 0 to n. Okay, 0 to n, and then we will have someone is equal to someone plus, let me write for this one. Okay, code for this expression, the expression under summation. Okay, expression with summation, so it will be minus 1 to power n divided by 2n plus 1. Okay, now it will be like minus 1 to power, it is I, and divided by 2 times I plus 1, and let it be in double precision. Okay, this is also in terms of double precision. Okay, this gives the terms inside the summation. Okay, and for pi, okay, it is estimate value of pi is equal to then 4 times, it will be sum. Okay, now we need to define here pi real. Okay, pi real will be 4 times 810. Okay, 1.d0 for double precision. Okay, now we need to this value gives you the value of estimated pi, value of pi, and let also write the error formula for error here into absolute value. Okay, of pi real minus pi estimate divided by, okay, it will be pi real. Okay, now we need to print the result. For printing the result we just use the write command also. Okay, and let it be as I. Okay, and obviously pi real. Okay, and pi estimate. Okay, and then error value. Okay, the output will be there, the output will have 3 and 4 columns. Okay, I, pi real, pi estimate, and pi error, and error. Okay, and do and program. Okay, so now let's check whether this code is correct or not. For this G Fortran. Okay, first of all we need to give the file in here. This is file name. Okay, okay, the code is correct now. So to see the output you have to type this one, and it says insert the value of n. Okay, n should be integer. Let me insert it as 10 first, then see the result. Okay, this is I, number of terms, this column contains number of terms. Okay, in Leibniz series, and these are the real value, pi real. Okay, so we have calculated this from using the arctan function, and this is estimated value of pi. This column contains this, and this is for error in percentage. Okay, see, for first term where n is 0 or I is 0, it gives value of pi as 4, and it has maximum error percent. And as I goes on increasing, percentage error goes on decreasing. Okay, so this what it shows is, if you use the large number of terms, then the percentage error will decrease. Okay, so let me also use the here 100. Okay, we use 10 terms, now we use 100 terms, then see the error. Okay, for 100 terms it is 0 point something error percentage error. Okay, so now let also see for 1000 terms. Okay, for 1000 terms, and it says this column, you can see the percentage error is more smaller. Okay, much smaller than before. Okay, now it is in the range of -10 to power -2 for 1000 terms in Gregory Leibniz series. So we have to save this data in the file. Okay, to plot this number of terms versus this estimated value of pi, we need to save the data in a file. To save the data in a file, we need to write the code. Let it be 10. Okay, unit is 10, and file name is, let it be gl Gregory Leibniz dot dat, and the action will be obviously write the data. Okay, and obviously you have to close the open file here. Okay, save it. First of all, let me show you. There is a presentation file, this is the code, and there are no data file now. But after running this code on Fortran, get, okay, now let check for 10 data. Okay, this is the data for 10 terms. Okay, and you can see the file there. Obviously this is the data file. If you open this, okay, it is not showing. I have to write the code for writing the file here. I forgot to come. Okay, so for this, what we need to do is again write command 1. Okay, this one means it contains the data from 10. Okay, from this. Okay, now let me copy this, and paste it here. Okay, so the file will contain 4 columns. Okay, save it and run the code again. Okay, for 10 data's number of terms. Okay, let's go to this file. See, it says reload. Okay, before there are no data, but after reloading it shows you the 4 columns of data, 1 2 3 4, and we will be plotting the graph, this column versus this. Okay, and this is the real value we have considered, so we don't need to plot this, we will only plot this and this. Okay, so to plot this data in gnuplot, what you need to do is, after installing gnuplot or Fortran on desktop, to check it, just type first 3 letter. Okay, 3 letter and press tab, and it will show like this if the software is installed in your device. Press enter. Okay, now I am on gnuplot software. Okay, and I want to plot this data on gnuplot. So to plot it, let me write plot, and file name, obviously it is gl.dat file, using 1:3. I write 1:3 because 1 means column 1, 3 means column 3. Okay, and first will be along x-axis, the second will be along y-axis. So let me show you. This is first column, this is third column. Okay, first, second, third. So we want to plot this versus this. Okay, let me click enter. Okay, warning, cannot find on file g.dat. I made a mistake there. It is in gr actually. Okay, press enter. Okay, it only shows the point right now. Let me change the line type here. Okay, with line point. Okay, and line width is let it be 2. Okay, line color will be LC. Line color LC will be let it be 10. Okay, press enter and go to the plot. Okay, see, the maximum value of pi by estimated value of pi is 4, and minimum will be less than 2.8. okay, it is about 2.6. okay, and see, as this is n, this is pi estimated, and as n goes on increasing, for minimum value of n, see, pi has value 4, which is not actually accurate, and for second smallest value it has 2 point something, which is not accurate also. But as n goes on increasing to 10, see, you can see the value of pi tends to converge to the value nearly 3 point something. Okay, see, so if you let me check the value for 1000 points. Okay, okay, I made a mistake. This okay, let it be for not 100 points. Okay, so data has recreated. Now we have 100 points of data. Okay, actually 101, from 0 to 101. okay, from 1 to 101. Actually there are 100 points of data. Okay, now to plot this, go to gnuplot again and type the same command. Okay, you can see now. Okay, see, now it is nearly 3.21. okay, for 100 number of terms of the series. Okay, we can also label the name. Let me label the name, and okay, let me create a file. Okay, actually, so this will contain the code for, let me copy this code. Okay, copy this code here. Okay, and set, okay, title will be derivation of pi value with number of terms. Okay, in Gregory Leibniz series. Okay, let me add title here for the legend, and this is, okay, it is estimated, yeah, okay, with estimated pi, value of pi. Okay, and also set x label. X label will be number of terms in Gregory Leibniz series. Okay, set y label. Y label will be estimated value of pi. Okay, let me save it now. Save it with pi dot gnu. Okay, dot gnu extension. You can also use the dot gnu or dot p. Okay, so save it in the same folder. Okay, now it is saved. So let here be replot also. Save it and load this data, this code on gnuplot. Okay, to load this we type simply load and pi dot gn. Okay, and press enter. Now it shows the plot like this. Addition of pi value with number of terms in GL series, Gregory Leibniz series, and estimated pi. This is, and x-axis, along x-axis we have number of terms in GL series, and along y-axis estimated value of pi. Okay, and see, as n goes on increasing, the value of pi goes on converging to the value of the real value of pi. Okay, which is 3.1. okay, you can see here 3.141 and so on. This is real value. Okay, all this column contains same value, and this value tends to converge to this value when n goes on increasing. Okay, so let me try also for 1000 number of. Okay, for this we need to quit gnuplot first and then run the code again. Okay, now I will just this. Okay, for 1000. Okay, now we have 1000 number of datas. Okay, we plot this versus this. So run the code again. Now go to gnuplot and run the same code. Okay, load. We have the code file here. Okay, this is data. Now we have 1000 datas. Okay, and run the code again, and you will get the plot which looks like this. See, now 1000 points. We have number of n up to 1000, and estimated value of pi, it is more converged to real value of pi. See, okay. If you want to save this plot, then you need to add just code here. So let the code be set terminal png Cairo size 1200 and 720, let it be 720, and the name of the output file will be, let it be pi value. Okay, pi value dot png. Okay, there are no image file right now. Okay, we have just, this is the code for plot, this is the data, this is the code for creating this data. Okay, and now if you run the code again, let me put the gnuplot first. Okay, sorry, we need to go to gnuplot and run the code. Okay, now we have this type of plot, and you can also see the image file there. Okay, pyvalue.png. If you open this, it looks like this. In this way, you can estimate the value of pi by using the Gregory Leibniz series in Fortran programming language. Okay, and you can generate the data which contains p number of terms in the series versus the value of estimated value of pi. Okay, and then you can just plot the number of terms versus estimated value of pi on gnuplot. Okay, in this way. So don't worry, I will provide all of these value files I have created in this video. During this video, you can check on the description box and visit the link provided in the description and get the file for your practice. Okay, I hope this video is helpful for you. If you find this video helpful, then please like it, and if you have any suggestions or comments, then you can leave the comment on the comment box, and don't forget to subscribe this channel. Your suggestion, your subscription, like and comment encourage me to make more videos. Okay, thank you.